Hello and welcome to a FortiWeb video on HTTP Header Security. FortiWeb's HTTP Header Security inserts security-focused headers into HTTP responses to enforce browser behavior, helping protect against client-side risks such as DOM-based XSS, data leakage, clickjacking, and abuse of browser APIs. Let's look at how FortiWeb helps strengthen client-side security by inserting browser-enforced headers. First, we have content and script source control. FortiWeb can insert headers like CSP, CORP, COEP, and COOP. These tell the browser exactly what content it's allowed to load and where it can come from. That means if an attacker tries to inject a malicious script or load something from an untrusted source, it gets blocked. Next is browser feature and API control. Here, FortiWeb uses headers like permissions policy and timing allow origin to control what browser features can be used. This helps prevent things like unauthorized access to the client's camera, clipboard, or even timing-based attacks that try to infer sensitive info. Then there's content rendering and execution control. FortiWeb adds protection using headers like X-content type options, X-frame options, and X-XSS-Protection. These help stop attackers from running code by disguising file types, loading your site in a malicious frame, or exploiting older browsers. And finally, we have data exposure and privacy control. Headers like refer policy and clear site data tell the browser to limit how much sensitive info, like URLs or tokens, is shared with third parties, and to clear stored data after logout, so nothing is left behind. So even though the threats are happening in the browser, FortiWeb gives you a powerful way to defend against them by setting the rules that browsers have to follow. And the best part? You don't need to touch your application code. Let's take a closer look at the headers on content and script source control. The Content Security Policy header restricts the sources from which scripts, images, styles, and other resources can be loaded. By default, it blocks the execution of inline scripts. For example, according to the directives defined in this CSP header, your site blocks scripts from a third-party domain because it's not explicitly listed as a trusted source. Inline scripts are also blocked by default, as CSP does not allow them unless specifically permitted. The CORP header controls whether other sites can load your resources like images or scripts. For example, this header only allows resource requests from the same domain. Requests to load your resources, such as images or scripts, from external origins will be blocked. The cross-origin embedder policy header requires embedded cross-origin resources to explicitly allow access via CORS or CORP. For example, your page has a COEP header in place that requires CORP. When it tries to load an image from an external origin, the request will only succeed if the external server includes the appropriate CORP header that explicitly allows cross-origin access. Only under this condition can the image be successfully loaded from the external source. The COOP header isolates browsing context to protect against cross-origin side-channel attacks. For example, a user on your site clicks a malicious link that opens a pop-up window. Without COOP, the new tab, attacker.com, could access window.opener and potentially manipulate or read data from your site, like redirecting the user, changing DOM elements, or stealing sensitive information. With COOP, the browser isolates your site's context. Window.opener is set to null, and the two pages can't share context or memory, blocking that risk. Now let's talk about headers on browser feature and API control. The permission policy header controls access to features like geolocation, camera, clipboard, etc. For example, to reduce privacy risks, set a permission policy so that the user's geolocation or camera can't be accessed by anyone, whether it's from your own site or from third-party content like ads and widgets. Any script that attempts to request geolocation or video access will be blocked by the browser, whether it originates from your site or from embedded third-party components. The time allow origin controls which origins can access performance timing data. For example, your developers use the performance API like performance.now to monitor page load times and diagnose bottlenecks. If performance timing data is accessible by attackers, they can perform side-channel attacks, such as detecting what resources are cached, inferring sensitive operations or authentication status, fingerprinting users based on load patterns. For example, attacks can guess whether the image is cached by its loading time. If the image loads very fast, it's likely cached. If it loads slower, it's likely not cached. Based on whether an image is cached or not, attackers can infer if a user has visited a site before or what content they've interacted with, tracking user behavior without using cookies. That's why it's important to set the timing allow origin header. If the request for performance timing data comes from your own site, allow it. If it comes from outside, block it. Now let's talk about headers on content rendering and execution control. These headers guard against improper content execution and UI-based attacks. The X-frame options prevent site loading in iframes to stop clickjacking. Let's look at an example to understand what an iframe is. A user receives a phishing email and clicks a link that takes them to a fake website. That site uses an iframe to load your real site inside a hidden frame. Here's your site, opened inside the iframe. The attacker then builds a fake interface. Most of your UI is copied, but some elements like buttons are altered. For example, they place a Claim Your Reward button directly over the real transfer button. So when the user clicks it, thinking they're getting a reward, they're actually initiating a fund transfer without knowing it. Setting the X-frame options header to semi-origin or deny can effectively prevent your page from being displayed in a frame, helping block clickjacking attacks. Semi-origin allows framing only by pages from the same origin, while deny blocks it entirely. Now let's look at the X content type options header. It prevents MIME sniffing to block disguised scripts. For example, you run a content sharing platform. Users can upload and download files, PDFs, images, spreadsheets, etc. You face the risk that malicious file being interpreted as something it's not, especially JavaScript. Let's say a malicious user uploads a file with a PDF extension, while the file actually contains JavaScript code. Some browsers may sniff the file and decide it's a JS file instead of a PDF. As a result, the browser might execute the file as JavaScript, which could lead to XSS or drive-by download attacks. To prevent the risk, you include no sniff header in your response. This tells the browser do not guess the content type. Always use the declared content type. Now, even if a file is crafted to look like JavaScript, the browser will treat it strictly as a PDF. The X-XSS-Protection enables built-in browser XSS filters. For example, your site has a search feature that echoes user input in the URL like this. Unfortunately, it does not sanitize input properly before displaying it in the results page. An attacker crafts a script in the link. If a user clicks that link, the page would normally execute the script and trigger an alert, a classic reflected XSS attack. To prevent this risk, you can set this HTTP response header. It tells older browsers, if you detect a possible XSS attack, block the page instead of trying to clean it up. However, keep in mind that this header is now considered legacy. Modern browsers like Chrome and Edge have dropped support for it. Today, Content Security Policy Header is the recommended and more effective way to defend against script-based attacks. Finally, let's look at the headers help reduce information leaks and persistent data exposure in the browser. The Refer Policy header controls how much of the URL is shared with other sites. For example, a user is browsing a page on your site that includes their user ID in the URL. On that page, there's a link to an external site. When the user clicks it, the external site opens. The question is, when redirecting users to an external site, are you allowing private information, like the user ID in the URL, to be passed along to that site? You can configure the following header to tell the browser, when navigating to a different origin, only send the origin, not the full URL path or query string. When navigating within the same origin, send the full URL. The Refer Policy header supports various values that give you granular control over how much referrer information is shared with other websites. The Clear Site Data header tells the browser to clear cookies, storage, and cache when a user logs out or when triggered. When a user visits and interacts with your site, the browser may store sensitive data, such as session cookies, cached pages or scripts, and data in local storage or session storage. To prevent this data from being stolen if the browser is compromised, you can configure the logout response to include the clear site data header. When the browser receives this response, it will delete all cookies for your origin, clear the HTTP cache, e.g. scripts, images, style sheets, clear local storage and session storage. This table lists all the values supported by the clear site data header. To sum it up, the HTTP Header Security feature strengthens browser-side protections without requiring any changes to your application code. Configured directly on FortiWeb, it enforces critical security headers like CSP, X-frame options, refer policy, and more. This helps mitigate risks such as XSS, clickjacking, data leakage, and privacy violations, ensuring safer user interactions with your web application. Thanks for watching.